Hello, good morning. So we are going to start our new type of class, is online class. So we basically use the Google Classroom, and today we will start the bar bending schedule of two-way slab. Okay. So I think you already know what is the basic difference between one-way slab and two-way slab. Sorry, but I can't able to make this so much interactive because YouTube live is taking at least 24 hours. So I think from tomorrow you will can join the active class. That means you can also join us in live. So now I am right now recording this in offline mode, and then I'll upload the video. Okay. So today I already uploaded the lecture note. Okay, this is the lecture note. So I have already uploaded this. This is BBS or bar bending schedule. Okay, no, this particular problem I discussed in the earlier class. That is, there are only some 5 or 6 number of students are present. So I will repeat this particular thing. So this is the BBS of beam, right? This diagram shows the beam. Now first of all we need to know the detailing of this beam. Okay, so here first you just see the numbering here 1 2 3 and 4, and this is 5 and this is 6, right? So and the 5 meter, this distance is called the clear span. I already told this is clear span. This is the width of the support. These two are the support, and this kind of bar is called bent up bar, right? So I need to calculate the length of this bent up bar or the cutting length of this bent up bar, and this 200 dimension, this is in millimeter, this shows the depth of the beam. Now I am going to the detail, that is what are the given data in this particular problem. The diameter of the bar is 12 mm, clear cover 25 mm, clear span 5000 mm, that means 5 meter. This is a 5 meter. You can see a distance from the inside of the support to the other inside of the support. Now slab thickness is 200 mm. LD, what is LD? LD is the development length. It depends on the strength of the concrete or the grade of the concrete on the grade of the steel. As per IS 456 or Indian Standard Code, you can calculate the value of LD with respect to those data. Now it is given as per structural consultant, this is 50D. Okay. Now what is small d? This small d is the diameter of the bar. This is a bar, so it has some diameter. So that is the diameter of the bar. Now determine the cutting length of the bent up bar. So I need to determine the cutting length. That means if I cut a straight bar and bend it like this, I need to calculate how much length it will require to make a single bent up bar. Okay. So cutting length, this is the cutting length. So cutting length I have calculated here. Clear span, so clear span of the slab. So what is clear span? Clear span is nothing but inside to other from one end to another end at the inner side of the beam. This is clear span. That means here it is clearly shown, that is 5 meter or 5000 mm. 2 into LD. What is LD? LD is nothing, this extra portion in both sides, these two things are called the LD or the development length. This LD is required to anchor, to make the anchorage between the beam and the slab. Okay, and here it is connected with the column as it is a beam. Now other thing, that is 2 into 0.42D. Now what is 0.42D? Okay, look, this is the 0.42D is the extra length required for this, for making this crank. Okay, suppose this is a straight beam. Suppose you just assume this is a straight beam. Now if I make some deflection over here, so the length will be changed and there is some extra portion required here. This extra portion can be calculated by making a simple triangle over here, and this is 45 degree because this inclination is 45 degree, and the depth, this the distance between the top reinforcement, that means this is the top reinforcement, this is 4 6, this is the top reinforcement, this portion is the top reinforcement, and this portion is the bottom reinforcement. So the distance between top and bottom reinforcement is called capital D. Okay, so here in this triangle, this distance is capital D, this is 45 degree. So what will be the value of this inclination line? This is simply, you can use the sine 45 degree, that means the perpendicular by hypotenuse. So it will give the value 1.42 D. Okay, 1.42 D. So previously the value is D and now it is 1.42 D. So what is the extra length? That is 0.42 D. Look, I have already shown here. Look, this is the triangle. So here this is D, this is X, I am taking here X. So sine 45 is equal to D by X. So X can be D by 1 by root 2, and here you can see is root 2 into D, that means 1.414, we can take 1.42 D. So extra length is 0.42 D, right? Okay, just 1 second, I am removing all these things. Now come to the next part. Now you can understand why it is 0.42 D, because here I get some extra length, here also I will get some extra length. So 2 into 0.42 D, and there is a part that is 1 D. What is 1 D? 1 D is nothing but, small d means the diameter of the bar, right? So here the diameter of the bar is 12 mm. So 1 D, that means 12 mm into 4. Why it is 4? Because when I am making a bend over a reinforcement or a bar, some portion, the length of the total cutting bar or the cutting length of the total bar will be decreases in a certain, in a small part. Okay, so that small portion is 1 D for each 45 degree bend. Okay, so each 45 degree bend I have to deduct 1 D. Okay, now what is 1 D? D is 12 mm, so 1 into D, that is 12 mm, 12 mm. So 1 D into 4. So for 45 degree bend, look here, this is 45 degree, this is 45 degree, here also 45 and here also 45. So each 45 degree bend I have to deduct 1 D. So here it is 1 D into 4. And for 90 degree, look here, here is a 90 degree bend, here is also a 90 degree bend. So 90 degree bend I have to deduct 2 D into 2. So ultimate solution, you will get the value, that is 5.98 meter. And whatever I already told, the capital D is already shown over here. So capital D is nothing but the center to center distance between the top reinforcement and the bottom reinforcement. Look here, it is 200 the depth of the beam, and the cover, look, the cover, the 25 value, here is a 25, this is clear cover. So there are two types of covers are there. Look this diagram, look at this diagram. So there is two part here. When the distance is taken from the extreme outer portion to the corner of the bar, this is called the clear cover, and effective cover, when I am taking the distance from the extreme end to the center of the reinforcement, this is called the effective cover. So I hope we'll understand the difference between clear cover and effective cover, right? Okay, so I can calculate the capital D value right now. So 200 minus, both side I have to deduct 25, here 25, here also 25. So 200 minus 2 into 25 minus 12. Why it is 12? Because I have to deduct here half dia and here half dia. Okay, because it is center to center. So here I have to deduct half dia, here I have to deduct half dia. So minus 6 into 2, that is also 12. Okay, so 138. Now I can calculate the cutting length, that means 5 clear span 5000. This is 2 into LD. LD is 50 D. Okay, 50 D means what? I am not shown the detailing over here. You can make a, you can take a copy and you can calculate. LD is 50 D. Here it is 50 D. So D is 12. So 550 into 12 into 2. Just put the value over here. 2 into 0.42 D, 2 and 0.42, and D. This D comes from this 138. Okay, so you can put one thing you should you should think about, that whenever you put a value, you should maintain the unit.